So for this lesson, we're going to be talking about transformations of quadratic functions. And for the warm-up, let's remind ourselves where we look on a graph for solutions of a quadratic function. And remember, you are looking for the roots of the function, which would also be the x-intercepts. You're looking for where the graph crosses the x-axis. Now remember, we've got translations. You've probably talked about these before. Okay, you can kind of think of translation as just when you slide something. Okay, so we've got transformations change position or size. One transformation, a translation, moves the figure up, down, left, or right. So underneath your notes, I want you to just write translation equals slide. When you are just doing a translation, you're not moving, changing the shape at all, you're just moving it around. Okay? All a translation is a slide. And so when we have a constant k is added or subtracted from the parent function, and remember our parent function is always x squared, the graph of the resulting function f of x plus or minus k is the graph of the parent function translated up or down. And remember, the parent function is x squared, as I just said. And so all other quadratic functions have graphs that are transformations of the graph of x squared. So whenever we have a quadratic function, it's in some way related to this x squared. Okay? Now, first thing we're going to talk about is the vertical translations. This is when you have something added or subtracted to x squared outside of parentheses. So vertical translations are outside parentheses. And if we add something to x squared, we're going to shift up. So that would be k is greater than 0. You can just put a plus sign next to that and then an arrow up. So when we add, we go up. That makes sense. If we subtract, we go down. So for example, if I would have x squared plus 3, I would take my normal graph of x squared and I would slide it up 3 units. If I would have x squared minus 7, I would take my normal graph of x squared and slide it down 7 units. And everything's going to be exactly the same. You're going to draw the graph exactly the same. You'll just start it 7 units down. All we're doing with the translation is sliding. So we want to describe how each graph of each function is related to the graph of f of x equals x squared. And f of x is always going to be your blue one, so that's your original. Green is the new one. So we have h of x equals x squared plus 3. Well, what happened to this graph? You can see we added 3 outside of parentheses, so the graph moved up 3 units. Because I added 3 to x squared, so I took x squared and I just slid it up 3 units. Notice, it just changes my vertex, it moves up 3 units. In part B, we have x squared minus 4. Well, blue is my original, green is my new. How did I change? The graph moved down because I subtracted outside of parentheses. 4 units. I subtracted 4 outside of parentheses. So now I slid my graph down 4 units. That's all it is. Add or subtract, add go up, subtract go down, and remember this is for when you are outside of parentheses.